the presenter over to Anya. Anya, are you there and ready to go?
I am, thanks, Erin.
All right.
Okay, I'm just going to show my screen, hopefully.
We could see it, so you're good.
Excellent, thank you, Erin. Good morning, everybody. This is a webinar to cover the basics of cmdop and FMCommand and give you a little preview of scripting and batching, command line processing. That portion of it will be done by Paton. We have a feeling that cmdop and FMCommand are so much in the background that maybe people actually aren't aware of these tools that are available to everybody that has a Fledermaus license, be it Viz 4D all the way through to FM Pro. The only exception to that is that FM Pro, FM Hydro are the only ones that have the Pfm applets available in it. But I think there are only about 4 of those. So the rest of the bundles get all of these applets that we'll be presenting, and you'll find them all in FMCommand or on the command line for whatever bundle you happen to have. The applets, these are little command packages that you can utilize. They cover a wide spectrum of functionality that's within Fledermaus software, so that you can, rather than being forced to work in the GUI, you can take a lot of those operations and processes and do them on the command line. Provides additional powerful tools to use in conjunction with the Fledermaus visualization or dmagic GUI functionality. So they're added tools, and I'll highlight a few that I think are interesting, and basically I'd hope that after the webinar you'll go hunting through the FMCommand listing and just see what we've got available there. cmdop also provides the ability to script and batch large or repetitive processes. That's a very powerful tool for processing houses and surveying companies. Also for academics who have a great deal of crunching to do with grids or data that they're pulling in. Also provides the ability to integrate these applets and scripts with other software or processing systems, and one example of that is Ascii.
Anya, sorry to interrupt, just yell as loud as you can. People are having trouble hearing you. We tested the mics out before we started, and to the whole audience, if you can, help us out and bump your speakers up as much as you can. Anya has her mic is up as far as she can, so if you can find your volume and turn your speakers way up, and we will do our best to speak loudly and clearly, and hopefully we can get everyone to hear us. Sorry to interrupt. Go ahead.
Okay, I will endeavour to speak loudly, and I'm going to lean right into my computer, and hopefully that will also help.
That sounds great. Go for that.
Where are these applets? Where do they reside? How can I find them? There are 2 ways to access these applets within the Fledermaus software. One is through the terminal window, i.e. on the command line, utilizing the application called cmdop. So any applet that you want to utilize has to be preceded by the phrase cmdop for it to operate. This provides the ability for people who are very comfortable on the command line. It also provides basic ability to run the command singly, but more importantly to actually batch process, to take the time-consuming work out. You just write a script, run it in the background, come back later, it's all done and dusted. The second way is through the application called FMCommand. It's a graphical user interface application. It provides people who are not that comfortable working in the background of their system with the ability to actually use it in a GUI. It's interactive, and it enables you to point, click, drag, use all the structure of your actual system that you're operating on. Right, just taking the first look at cmdop. If you're in a terminal window, for Windows you type cmdop-H, which is help. If you are on a Mac at the moment, you actually have to point to where the cmdop executable is sitting, and that's in Applications, Tools, and in this terminal I'm actually sitting within that, so all I have to do is /cmdop-H to duplicate the Windows operation. What that gives you is every single applet that is available. It's grouped by functionality, and moving ahead, if you want specific help on one of those applets, you insert the name of the applet in between cmdop and -H to receive the requirements, the output, the choices that you have to make to actually utilize that applet. The second way to gain access to the applets is through FMCommand, the graphical user interface, the GUI. And as you can see here, this is the icon, and this is what it actually looks like. It's broken out by a listing on this side of all the applets available, grouped by functionality. Up here, current working directory, that's where you're actually working from, and it's best to actually move to the directory that you want to grab the files from or write to, and you do that by selecting the Browse button. The command, this is where you either type the command or construct the command using the applet. This is the usage information area, so when you click on a command here, it will populate this with the help. And when you actually hit return after the command, this is where the results will be shown, and your surface or grid or whatever you're producing should be populated in this area here, files in the current directory. I'll just go out and show you how to find it in a Mac. So it's Finder, unless you've got it on the sidebar like I have it, you go into Applications, you look for IBS Fledermaus version 7, and you find FMCommand, and it's just a double click. And just repeating what I had said with my slide, this area here is a listing of all the applets by functionality with a brief summary afterwards of what it does. This area here, current working directory, just operates as your system does to find the directory or the files that you wish to utilize. And if you change that, it populates this area with all the files that it finds in that current directory. This is the command line, so if you click on a command, it will populate that and provide you with the help. And down the bottom here, if you run a command, that's where that will appear. Now on Windows, just so that you can find there, it's very similar, Fledermaus version 7, and you're wanting to go to FMCommand. Whoops, sorry. FMCommand there. As I said, they're grouped by functionality. So we've got color map tools, e.g. for example, color map info, make color maps. You can construct your own color maps. Imagery related, anything that you're going, any process or import that you're going to be doing on an image file, that's where you should look for that applet. Miscellaneous, these are the interesting ones, and often within the miscellaneous grouping, the functionality of the applet is not duplicated in the GUI or Fledermaus or dmagic. So, you know, if you're wondering whether we do something particular or very specific, I would look under miscellaneous in that list of applets for an interesting set of commands. Pfm Support Tools, those are the ones that are only available to FM Pro and FM Hydro, the bundles that actually enable you to do processing. DTM scalar manipulation, fairly obvious. Any manipulations you want to do to DTM, surfaces and scalar. SD file builders, these are actually taking raw data, source data, Ascii files, any data that we actually support and doing a process on them. Gridding them, making a surface series, making a vertical curtain from an image. But what it's producing is that data object, that SD, that is going to be visualized within the Fledermaus environment. Surface importers, there's a lot of useful tools, applets in there. You can import a large variety of surfaces, bag, arc, eTopo, and they're useful. I mean, this is duplicated in the GUI, Fledermaus and dmagic, but it's useful because these are things that you're actually going to be using in your scripting and batching. TDR utilities, that is to find out information about the Fledermaus structure, file structure. So find out information about the SDs, find out information about the scalars, find out information about the image data objects, so that you can utilize those to actually find out what you've got in those Fledermaus data objects. Move making tools, fairly obvious, and depreciated tools. If it no longer functions, or we've supplanted it with another applet that has better or greater functionality, but we know that a few clients actually have a use for the depreciated tool, we will leave it in this list so that you can use it. I would be very wary because there's a lot of well, not a lot, but there are commands in depreciated tools that were specific to working in version 6 environment, and they will not work in the version 7 environment because version 7 is expecting certain things, for example, a coordinate system to be supplied. What are the basic requirements to run an applet? I've just listed the info from cmdop for Gridder, one of the applications, because it's a good example of what you might be needing to input on the command line to run this command. The first is fairly obvious. You want your input files, your source files. In this case, you can put a list of files, file 1, 2, and any number actually on the command line, list them, or you can go to a directory and use a pattern, a file pattern, star.gsf for example, to select the files in that directory that you wish to use. You need to provide an out file name, so what do you want this SD data object to be called? iCoordSys is the import coordinate system. This needs to be the coordinate system for the data that you are inputting, i.e. what your data is in natively. Output coordinate system, you can choose to transform that data at this stage into something else. Bounds, For Gridder, you are required to specify the geographic bounds to produce this grid on the command line. Cell size, again, what's the resolution of the grid that you're going to be supplying. Now, you can see that those first 6 are in the acute brackets, the pointy brackets. That means that that field is required for this function to, for this applet to function. If one's missing or incomplete or it can't find the file, nothing will happen. The following ones in square brackets, these are optional. Some of the square bracket options are actually required, but there is a default value that the applet will provide if nothing has been specified on the command line. A good example here is type, i.e. what type of algorithm are you going to use to grid this up? I want to use the weighted, shallow, median, deep, RMS. You can specify that after the type option on the command line. If you don't, the default is weighted. Another good example is the diameter, the weight field diameter. If not provided, it uses, I think it's 5. Yes, it is 5. But the rest of these do not need to be specified for the applet to function. In version 7, many applets actually need an input or an output and or an output coordinate system to be specified. A useful applet available to you to find this out is called listchordsys. It'll be able to provide you with the EPSG code or a list of the commonly used coordinate systems, or the alternative is actually going into Fledermaus and looking at that, searching in the coordinate system drop-down box. Both are valid, and both are going to supply you exactly the same information. Listchordsys will also find central meridian and or zone for UTM projections for you. There's just listchordsys on the command line, so I've just typed cmdop listchordsys help, and it lists the options, describes the options, and then gives you some examples of how to structure your command. Another very useful applet is project points. It allows you to project ASCII point files, allows you to basically transform geographic ASCII or any supported data to another coordinate system, and also allows you with files where the data is YXZ to actually specify the order that we expect it in, so XYZ. And again, what you see here is the cmdop, the applet name, and the help, and it lists the options, and then all of the help to explain the options. Another very useful applet is Gridder. Now this produces a surface SD file from source files. These source files can be any format that we support. So that's GSF, .all, ASCII, FAL. As long as we support it in our software, we're going to support it here. You'll notice that there's quite a lot of help provided for these commands. So following the options, it's very worthwhile reading the description, because it does elaborate on exactly what is going to happen when you choose these options or don't, as the case may be. Okay. At this juncture, I just wanted to pop out to FMCommand and just, oh, sorry. And show you Gridder. So just show you how you go about operating. Now I've lost it. There it is. Under SD File Builders is Gridder. So that pops that command into the command area, gives you all your options, gives you your help. I've already gone to the area where my source data is, so I'm already sitting there. You can see that it's listed here in the files in the current directory, and I've already actually typed the command that I'm going to use, but I'll work through it. I just wanted to avoid mistyping something and having failure. So okay, in FMCommand you don't need to use cmdop, so it's just that straight. You start with the applet name, Gridder. Then I've decided that I'm going to specify the files I want to use by a pattern. So I've specified that in pat*.gsf. I've named my out file gsf_gridder.sd. I've specified the input coordinate system as geographic, WGS84. I've specified the output coordinate system as the same, but this is where you can choose to project it, to use a projected coordinate system if that's what you want your data object to be created in, so that you can utilize it in a scene that's already in that coordinate system. Bounds for Gridder must be specified. So you've got your X minimax, your Y minimax, and your Z minimax there. Then cell size in your units of your data set. Oh, sorry. And that is it. So that should produce from the files here a grid. And it takes the command and it then starts the program and it specifies the information that you've supplied: cell size, weight diameter. It calculates the rows and columns for the grid. There's the input X, Y, and Z minimax. There's the directory pattern the directory and the pattern that you specified, and it finds those files that match that pattern. And you can see that it's created the object there. And if I go to Fledermaus, I did cheat, I had done this previously. File, open data object, you would select that, and there's your grid that you just created on the command line. Okay, moving on to the miscellaneous area, where all the interesting applets, well, I think, appear to be contained. There's one that is quite useful if you're trying to manipulate, constrain surfaces and imagery and combine them in a particular way. This gives you a little bit more power than you actually have within the GUI. Surface mask gives you the ability to mask a surface using a poly, another surface, oops, sorry, or a plane. And at the top of the screen I've just typed from FMCommand. It's surface mask in the surface that you want to mask, what you want the output data object to be called, the masked data object, what you're using to mask this with. In this case I chose a poly. You got to give the name of the poly and whether you want to mask inside or outside that whatever constraint you have given it. And this is the original surface, so this is test model SD, and you can see that I've got the poly. I've picked a poly around a feature that I want to mask out. And this is the surface, the output mask.sd, after I have used that poly to mask. It's got a nice hole in it. Nice and quick. Another very useful command, an interesting command, is build surface model. This creates a berm or a trench in a surface. So you specify the width, the offset from the surface or seafloor. You specify the surface that you're using. You also have to specify an XYZ, a route for your trench, your berm. Name your output, and then these are the options to give the width and the offset from seafloor. What you want, I want a berm, and I want it to fill the surface, to create the surface complete, not just the berm. And what you get when you run that, well, that's the original surface. So that's test model SD. What you get is a berm, which is offset from the sea floor by 12.5 meters with a width at the top of 5. At this juncture, before Mark, I hand over to Mark. If anybody has any questions, I can take them now.
Hey Anya, if anybody does have any questions, now is a good time to pop your hand up or type a question in. But can you, I hope you can do it without screwing yourself up, can you open FMCommand and just show them how you can populate the command line by clicking on the info?
Sure. So what Erin is speaking about is you choose a command, and so the very first option that we want here is in, and so that puts that option in. So I want that file, and then out I want it to be called test.sd, iCoreSys. So you can go through and populate your command line like that. And and thanks for that, Erin. It's good to avoid any typos because this is very unforgiving. You have to get it exactly right. No spelling, no spaces in the wrong place, etc.
Okay, thanks for that. Yeah, if you do type something, be careful about putting a space before the next command. That always catches me. And can you explain when you were saying, I think, in Pat, how you brought in a bunch of files? Can you just explain what that means?
Sure, it's actually right here. So in Pat is input the pattern of the file. So what you're going to specify is here in this directory I've got GSF and NSF. I want it to ignore the NSF, so I'm going to specify the pattern, i.e. the suffix that I want it to grab, and in this case you've got to say I want all files with the suffix .gsf, so it's star.gsf. And there is an example. It starts just here as a pattern for example, using star.gsf as the pattern would grid all files ending in GSF in the directory that you're sitting in or the directory that you specify. I think there's no, there's not an example down the bottom there. Does that help?
Yeah, that was great. The one question we did have during the session, you can't expand the command window up there, can you, where it populates the command?
No.
Okay.
I haven't been able to in my Mac environment, but I am a bit of a newbie to Mac, so I might be missing something. What you mean is, it drives me crazy as well. You want to see all of the command, and beyond stretching it right out, I haven't found any way, because these sidebars seem to be a fixed width in relation to the central portion.
Okay, that's what I thought. And Mark,
Yeah.
when you come on, if you have any secrets that you can share with all of us, that would be good.
And if not, we should add more features.
That is the way it is.
Okay. Thanks, Mark.
It's annoying.
All
okay,
right.
If there are no other questions, what I will do is hand it over to Mark. And thank you very much for your attention.
Maybe, Anya, you can just keep it on your screen for a minute, and just because you have the slides, and I'll just talk to the 3 slides, and then we can try and switch it over to my machine to run the demo.
Oh, you don't have the slides up?
No.
Okay. No, I will do that. 1 minute.
Okay. So I was just going to elaborate a little bit more on, instead of doing the a one-off command once in a while, trying to put a couple of commands together to do useful work. And there are a number of applications, depending on what you're trying to do, where you can save a lot of time and effort from doing repeated tasks, and that's the goal of sort of scripting, or we call batch jobs. And that's exactly as it says. How do you do more complex tasks by combining commands together? Can you go to the next slide? So really, there's batch files. I tend to separate batch files, which is more comes a very specific term from scripting in general. Sorry. And what really batch files are most commonly for Windows users is when you're on a command line, and you can just create basically the commands that you would type along on the command line. You can basically put in a file. Sorry, let someone call me there. And run them as a batch file. Same thing when you're on a Linux or Macintosh machine. It's the typical shell scripts, bash or C shell scripts. They're commands that are one after another, and they're very convenient way to just to do a whole series of commands. But you don't have a lot of ability to control the data flow. So you can run the commands, but not a lot of options, and that's where scripting comes in. Anyways, if you can switch to the next one there. So what do scripts do? Scripts is really it's an evolution of the batch files. It's to allow more sophisticated processing, and it's to do things like look in these directories, grab these source files, combine them together, and pass the data into the commands. And there are many scripting languages. There are 3 in particular that I would say I've seen the most use, and I've certainly used myself. And the 3 are most commonly, other than the simple batch scripts, is Perl, which essentially allows you to do anything. It runs on every platform out there. It's one of those languages where it looks really easy, and it's easy to do things quickly, but you look at what your script 2 months later, and you wonder how it, it's not clear how it works. It's a very obtuse language. Python is another popular scripting language, which is more like almost like a C-style code that allows you to chain together applications and do very sophisticated processing. And the third one is more commonly used when you're doing web presentations. You're actually doing data processing, and you're making a web page, a front end, to do the access. So it has a lot of the generality of the other 2, but has great support for basically web front ends on it. And those are sort of the three kings of the script files. Okay, if we can try and switch it to my screen. So Aaron, okay, show my screen. So is everybody, Aaron or Anya, can you confirm that you see my screen okay?
I do see your screen, yep.
Okay, so here, here's a simple example of just a simple DOS batch script, which I've called gridit.bat, and basically I'm going to run cmdop. I'm going to grid some data that exists in the data directory, some basically GSF files. As Anya talked about, specifying a coordinate system for input-output. I need to specify cell size and output file names. And the only real trick with the batch scripts is you don't have a lot of control, but you can specify your arguments that you run on the command line. So when I actually run the command, I'm going to run it, gridit.bat. The first argument is going to be test1, and the second argument is going to be a number. And those correspond to these %1s and %2. %1 is the first argument. It's going to be test1. %2 is the second argument. And that's how you can do very limited data flow, but it has to be very, very, very direct. And same thing in the output files here. I'm going to build basically, I'm going to grid my data and produce a geographic surface within these geographic bounds. And then I'm going to produce 4 more surfaces, basically at 1 meter, 2 meter, 3 meter, and 4 meter resolutions, this time projected into zone 19. This is going to be some data around Portsmouth Harbor in the US. And my file name is my output name is going to be whatever was on the command line, so test1. It's going to be test1 UTM 1 meter, and so on. And it's these little substitutions with the percents which make your script a little bit more flexible. And after I produce these SD files, just as an example of sort of tying the data flow, if I want to go from source data to a gridded product and then export it to, say, ARC in this case, or Esri's product here, there's an export surface command which is going to take in my 1 meter data set and convert it to basically an Esri ASCII grid.
Hey Mark, can you hold on 1 second?
Yep.
Okay, somebody wasn't getting a refresh and they were still seeing the presentation, but it fixed itself, so continue on.
Okay, so this is the process. It's pretty explicit. Produce geographic surface, produce 4 UTM-based surfaces at different resolutions because I want to compare them, and I'm just going to export one of them as an Esri ARC surface. And you can see my directory is basically empty now. So gridit.bat, we call it test1, and that second argument here is just going to be the geographic resolution. And around, I'm sort of familiar with the geographic to UTM. That's about 2 meters resolution for the requested cell size. If you took that's decimal degrees basically. So we let it run, and it won't take this very long. You'll basically just see it's running the programs one after another. It's the same output you would have seen if you had to run FM command, and it's just reprocessing it. And one of the big things people do that I've observed is people have a directory, like in this case my data directory, and I'm looking for all the GSF files, and if it's a survey or something that the data directory changes every day, you get new data in. Basically, the script is run each day. You generate all your products with day 1 plus day 2, day 1 plus day 2 plus day 3, and so on. That's where you can kind of take advantage of the scripts. So now that it's done, you'll see I have test1, the geographic surface, UTM 1 meter, 2 meter through 4 meter surfaces. And if I just load one, for example, One thing I might know is if you've ever observed on Windows problems when you double-click a file and it seems to take Fledermaus a very long time to load. That was something that's been we discovered and recently fixed in the C version that's currently 722C that's up on the web. So if you've seen that kind of problem before, definitely get the updated version and it'll go away. So you can see the surface that I produced. You can actually see the cell size as projected now into meters, and it was roughly 2 meters in wide, but of course it was square in geographic space. When you project it, the cells aren't square in meters. That's why you have a little less width as you go further north from the equator. Same thing if I look at the 1 meter surface, and I'll actually load the other ones as well here. Hide them all. So going from the top-down view, so this would be your 1 meter gridded surface. I'll hide that. Your 2 meter, using less holes, but obviously some smoothing effects because it's now at 2 meters rather than 1 meter. Again, 3 meter and 4 meter. So those are the set of surfaces that were produced from the script. And we also produced that Ascii file that was exported to the Esri Ascii format. So I just take a quick look at that on the command line here. meter.ascii. Oops, 2 meter. You see a typical Ascii file with a no data value. And there's no data, and if I eventually scroll through it, you'll start to see some numbers. And that's just an example of taking data from raw files into grids and exporting them out as a product for another application to bring in. So that's example 1. And then I started working on a second example, which was more of a Pfm based one. And so I'll switch to it here. And again, and that too was a simple batch file, taking the commands, putting them up together with very limited control. The second example is actually a Perl script, and it's remembering how trying to remember how to do Perl. And you can see there's a number of advantages that a Perl script has. It has things like variables, like here's an example of identifying where I'm going to store color maps. You can do sophisticated processing on arguments. You can read data from directories, so you could check dates of files. There's a whole you basically have very detailed flow control over what you could or couldn't do. Now, I don't have my Perl script very well flushed out here, so I'm just going to do a very simple one where I'm just going to have a list of files that I'm going to process, and I've just hard-coded them here. And I'm going to basically do 2 commands, which is to initialize a Pfm. Pfm is the data structure we use to do editing. So if you have raw data that you need to do cleaning on or editing operations on, normally to do that graphically, you would use the demagic application, add your files, select an area and process it. I'm basically doing the same thing, but in a command line approach. I'm going to run the, initialize a Pfm with a name that I provide for a particular cell size, depth range, and area. And then I'm going to do basically add some lines to it and run it. And this is the way that Perl, for example, sets strings. And actually, when you have that backtick command, it basically says run whatever is in the command, and it'll launch that command and run them one after another. So in sample 2, you can see I have the build it Perl, and I've downloaded, installed Perl on my Windows machine. It's a free thing you can do. The script, and I'm going to call it my survey 3meters.pfm, and basically say go, and it's going to start running the script and processing it. And one thing that I noticed, Anya and Aaron, that there are a number of PFM tools that actually do not show up on the help, or do not show up on the FMCommand. And in particular, there's basically a PFM unload, so you can unload PFMs. That's when you propagate your edits back to your source data. You can export surfaces from PFMs and also export any of the filtered soundings that you do. So we'll definitely add those to the. It should be in the help. I just realized that while I was writing the script. So I've built my PFM now. You can see here the PFM and the data directory that actually has the structure. If we run Fledermaus and add that PFM, sample 2. So basically, I just did a small area, obviously, to make it fast for the purpose of doing this demo. You know, any of the typical editing tools that you do, and then you could use Fledermaus, do your editing operations, do your filtering, and carry on. And often when people write scripts for PFMs, they do it in a daily basis. Like they want to add they set up the PFM, and then each day or each couple survey hours, they come back and add more lines to the survey, building it up over time. And you can again fully automate that with a little bit of scripting experience. That's basically the demo where I got it to. I'm going to continue to flesh out this example so we can, Aaron, if anyone has any interest in getting a couple sample scripts for PFM processing and gridding, we can certainly provide those as a basis for helping you get started.
I'm sure many people would be interested in that, including myself. So if we can get those all bundled up, I will have them and make them available.
It's like the PFM export is one of the ones that's missing, I noticed, in PFM unload.
And you got 2 hits on that. So 2 people have expressed interest so far. So if you can, now that you've said it, you have to provide them.
Oh, well, yeah, where those were mostly used is one of the big areas where scripts are often put is integration with other systems. So whether it's working with Ascii tools, for example, they have their applications where they have the front end, they select areas, and they launch basically we put scripts together, and they launch the scripts, it builds a PFM, it does edits, and they do all their editing and work in Fledermaus, and then they basically hit one button, and all the data then flows. There's a few more scripts that push it all back into ARC, and then they continue on. And we've done it with Optech, for example, for some of the LiDAR processing, where you have tools that can launch other applications in the background, and you can make a very user-friendly, essentially front end onto some fairly complex processing with a little bit of thought and knowledge of the scripts. And some people have done some pretty extensive things. Anyway, those are just the 2 examples that I have. If there's any specific questions, or anyone has want some ideas, I'm always willing to answer those.
I don't see any questions right now. I'll see if anyone has their hand raised. I think just to kind of summarize, if you are not someone who does scripting, or you've never done scripting and you don't know anything about it, FMCommand is nice. You can't batch things in FMCommand, but it lets you run tools that aren't available in the user interface. Things like DTM merge, which will merge your SDs together. And there's a few other ones that only exist there. And that, if you're not a scripter, that's a nice tool to have in your tool belt because there's still a lot in there. If you can script, using the batch scripts, you can really speed up your workflow and trigger other operations. And that's what I think Mark was kind of talking about with the scripting to Esri and OpTech and stuff that we did.
Yeah. Well, for example, too, you can make the magic projects automatically. So if you have a survey or a workflow where you have a lot of data, you can actually make a script that completely sets up the dmagic project. So instead of having to say run dmagic, create a project, add the source data to the project, and go from there, if it's a repetitive task that you would typically do in a survey, you can make a little script that's sort of like set up my project, and with a few options in it, you could very quickly have it help you in that. Save some time in that data flow, and I often, when I'm doing scripting, I tend to keep the two tools up, FMCommand and an editor beside me, so I'm using this to click on the commands to see the commands and verify it, and then a command line window at the bottom, and the three together makes for a very powerful little testing, scripting, running interface, and that's basically what I do with respect to scripting.
All right. Thanks, Mark, and thanks, Anya. Anya, do you have any last thoughts before we sign off? Nope, no. Just happy to be done.
I'm afraid I have to be honest. Yes, I'm pleased it's over.
You did great. All right, I don't see any hands up or anything. So if anybody has any questions, please feel free to contact us and we'll get back to you, either support if you're a client. If you're not and you're just interested, you can email me. It's ehefron@ivs3d.com. If you are a client under maintenance, we recorded the webinar and it will be available shortly, probably early next week. It does take a while to process the thing out. And I'm now going to pressure Mark to give some sample scripts because I saw that quite a few folks were interested in that. So I will have those available, and if you told me you're interested, I'll make sure to send them along to you. If you decide later that you are, just again send us an email and we will help you out, either support@ivs3d.com or ehefron@ivs3d.com. I think that's it then. So thank you all again for attending our webinar, and thanks to Anya and Mark for presenting, and hopefully we'll see some of you again next month. Thanks.